Welcome to the Dividing Fractions Guided Notes. Let's get started. This first page is a quick review of what division actually means. Division can be thought of in two ways. Let's look at 12 divided by 3. So 12 divided by 3 can mean 12 is the total amount of items, 3 is how many groups, and 4, the answer is how many per group. We can also think of 12 divided by 3 as 12 is the total amount of items, 3 is how many per group, and the answer is how many groups, 4. Let's look at the following division problem. 3/4 divided by 1/4 equals what? So 3/4 is what we have, 3/4, and 1/4 is how many per group. And our solution is how many groups. We will use a visual model to make sense of these fractions. There are 3/4 items to start, so we are going to shade in 3/4. Dividing by 1/4 is asking how many per group. So how many groups of 1/4 are in 3/4? So let's circle groups of 1/4 on the model. Here's one group of 1/4, here's another group of 1/4, and one more group of 1/4. So there are 3 groups of 1/4 on the model. Therefore, 3/4 divided by 1/4 equals 3. Now let's do the following problem. 6/5 divided by 3/5. So 6/5 is the same as 1 whole and 1/5. So we are going to shade this on this model right here. So we have 1 whole, one entire thing, and then we have 1/5. Dividing by 3/5 is asking how many groups of 3/5 are in 6/5. So let's circle groups of 3/5 on the model. So here is one group of 3/5, and here is another group of 3/5. How many groups of 3/5 are on the model? There are 2 groups of 3/5 on the model. Therefore, 6/5 divided by 3/5 is 2. Now we will divide 5/6 divided by 2/6. So we need to model 5/6 on the model. So that means my 6 on the bottom tells me how to break up my box. So I'm going to break it up into 6. Now 5/6 is going to be 5 of those. How many sections should you make? Well, we made 6 sections and shade in enough sections so the model shows 5/6. We did that. Now you want to determine how many groups of 2/6 are in 5/6. So let's circle groups of 2/6 on the model above. Here's one group of 2/6, another group of 2/6, and I cannot make another group of 2/6. I need 2 of these. So this is going to be half a group. So it looks like I can circle 2.5 groups, because one group is 2 of them and I have just a half here, so that's going to be half of it. So 5/6 divided by 2/6 is 2.5. Model 1/5 divided by 2/5 on the visual model. So my first number is what I have. I have 1/5. So I need to show. That means I need to divide my bar up into fifths, and I am going to color one of those to show 1/5. How many groups of 2/5 are in 1/5? So let's circle groups of 2/5. A group of 2/5 would be 2 of these, but only one of them is colored. So that's just going to be a half. I have half a group. So 1/5 divided by 2/5 is 1/2. Let's summarize the data. So these are the problems that we have already done. 3/4 divided by 1/4 is 3. 6/5 divided by 3/4 is 2. 5/6 divided by 2/6 is 2.5. And 1/5 divided by 2/5 is 1/2. What do you notice about the denominators in the division problems? If we look at the denominators right here, Notice that the denominators are all the same. How are the numerators associated with the quotient? Notice that 3 divided by 1 is 3. 6 divided by 3 is 2. 5 divided by 2, well, that would be 5 halves, but 5 halves is the same as 2 and 1 half. 1 divided by 2 is 1 half. So if my denominators are the same, the quotient of the numerators is the same as the quotient of the fraction. In summary, if the denominators of two fractions are equal, then you can divide the numerators to get the quotient of the fractions. What could you do if the denominators are not equal? And we see this with adding fractions and subtracting fractions. We need common denominators to add or subtract fractions. So if they're not common, well, then we make common denominators. How can you make denominators equal? We find the least common multiple. Let's change 1/2 divided by 1/4 to have common denominators. The least common multiple, LCM, of 2 and 4. If you don't remember how to find the least common multiple, I'll write it right here. So 2, we're just going to list multiples of 2. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. And list common multiples of 4. 4 times 1, 4 times 2, 4 times 3. My smallest number that is common between them is 4. That is my least common multiple of 2 and 4. So I'm going to change them to 4. Remember to multiply the numerator and the denominator by the same number. So my 1/4, I don't really have to change because it's already 1/4, but my 1/2 is changing to with a 4 on the bottom. So I'm going to multiply 2 times 2 is 4. Therefore, 1 times 2 is 2. So now my problem says 2/4 divided by 1/4. Let's model 2/4 divided by 1/4 on the visual model. I have 2/4, so I will show that by dividing up my model into fourths. 2/4 would be 2 of those. So now it says, how many groups of 1/4 are in 2/4? Let's circle. 1 group and 2 groups. So there are 2 groups. Let's check using our algorithm. Since my denominators are the same, then I can just divide the top. 2 divided by 1 is 2. And so it worked. Let's use the algorithm first to determine 1/3 divided by 4/9. Convert this expression so they have common denominators. So I need the least common multiples between 3 and 9. So let's write down the multiples. 3, 6, 9, 12. And multiples of 9 would be 9, 18, 27. I already noticed I have a common multiple right here of 9. So that's going to be my denominator. 3 times 3 is 9, so 1 times 3 is 3. And then my 4/9 will not change. So now that my denominators are the same, I can divide the top to get the quotient. So 3/9 divided by 4/9 would be 3 divided by 4, or 3/4. Let's use a model to show the quotient visually. So let's show 3/9 on my model. The first number is always what I start with. I have 3/9. So I'm going to divide up my model into ninths. 3/9 is 3 of these. Now I need a group of 4/9. So if I circle one group of 4/9, that would be this right here. But I only have 3 of those 4 circled. So that's going to be 3/4. Practice. Divide the following fractions. Show your solution with a visual model. Now these models are often given more boxes than we need. It's just in case if you do it a different way. But we will not use all the boxes if we don't need to. So we have 1/2 divided by 1/8. So let's get common denominators by finding the least common multiple of 2 and 8. So 2, 4, 6, 8, 10, 12. And of 8 will be 8, 16. I'm going to stop because I notice a multiple right here of 8. So I'm going to change my denominators to 8. The second one will still be 1/8. And then 2 times 4 is 8. So 1 times 4 is 4/8. So 4/8 divided by 1/8. My denominators are the same, so I can just go 4 divided by 1, and that equals 4. Let's show this on a model. So 4/8 means I'm going to divide up my fraction into 8s. 4/8 will be 4 of them, so dividing by 1/8 is asking how many groups of 1/8 are in 4/8. So here's 1, 2, 3, 4. There's 4 groups. Now let's do 3/4 divided by 1/2. My least common multiple, I can list it out, but you may know that it's 4. So it's going to be 3/4. And then I need to change 1/2, so the denominator is 4. 2 times 2 is 4. So 1 times 2 is 2. Now my denominators are the same, so I can divide the tops. 3 divided by 2 would be 3/2, or I could also write that as 1.5. Let's show this on my model. I have 3/4, so I'm going to divide up the box into fourths. Divided by 2/4 means how many groups of 2/4 are there? Oops, I needed to shade 3/4 first. So here's 3/4. Now let's circle our groups. Here's one group of 2/4, and another group of 2/4 would be this. So this is one whole, and then I have half a group right here. So 1.5, which is the same that I got using the algorithm. 3/2 divided by 3/4. Again, my common denominator will be 4. This will stay 3/4. 2 times 2 is 4. So 3 times 2 is 6. So 6/4 divided by 3/4. So I'm going to divide up my model into fourths because that is my denominator. And I have 6/4. That's the same as 1 and 2/4. So I know that I'm going to need to use 2 of these model boxes here. So there's my fourths, and I'm going to shade in 6/4. So there's 4 and there's 2 more. So there are 6/4 right there. Now divided by 3/4 means how many groups of 3/4 are in 6/4. So let's circle. Here's one group of 3/4, and then another group of 3/4 would be this plus this. That's one group. And so we have one group, 2 groups. So 6/4 divided by 3/4 equals 2. Let's do that using the algorithm. So 6 divided by 3 equals 2. It's right both ways. 4/5 divided by 1/4. Let's get a common denominator. So let's write multiples of 5, which would be 5, 10, 15, 20, 25. We'll stop there. Multiples of 4 are 4, 8, 12, 16, 20. And then I have a common multiple right here of 20. So my common denominator will be 20. 5 times 4 is 20. So 4 times 4 is 16. 4 times 5 is 20. So 1 times 5 is 5. So I'm going to do 16/20 divided by 5/20. With my algorithm, Since my denominators are equal, 16 divided by 5 equals 16 fifths. That is the same as 3 and 1/5. So since I'm doing 20ths, I've got to divide up my model into 20ths. 16/20 means I'm going to shade 16 of these bars, which means I'm just going to have 4 left over. Divided into 5/20 means how many groups of 5/20 are in 16/20. So let's circle. Here's one group of 5/20, 1, 2, 3, 4, 5. There's another group of 5/20. There's another group of 5/20. And my last one is I have 1/5 left over right there. So I have 3 groups and then 1/5. You can see that the models can get a little bit messy when I'm dealing with bigger denominators. So it's always good to know the algorithm, but just have an understanding of where it comes from with the model.